A wireless network is a computer network that uses wireless data connections between network nodes. The advantage of wireless network is they do not require cables between the nodes. No, not this cable. This cable. But since it's a wireless network, we don't need cables. The drawback, perhaps, is that they typically require some more setting and that they can be influenced by the surroundings. Examples of wireless networks include cell phone networks, wireless local area networks, LANs, wireless sensor networks, satellite communication networks, and terrestrial microwave networks. From practical experience, you are interacting on daily basis at least with wireless LANs and cell phone networks. Wireless LANs are used to connect numerous devices such as laptop computers, smartphones, printers, gaming consoles, smart TVs, and others through wireless router. Through a gateway, they can connect to internet. These networks can be either limited to someone's home or intended for broader use, such as hotspots offering internet access at the airports or other public places. On the other hand, cellular networks, of which a cell phone network is the most common example, include several nodes called base stations and can cover large areas. As opposed to local networks, where the connection drops when the devices are too far from the router, a cell phone will always try to connect to the closest base station, or at least the one with the strongest signal, and even switch between the stations even while a call is in progress. This is called a handover. Wireless network optimization is a key aspect of network management that involves the refinement of network performance to provide the best possible user experience. When setting up a network, the key thing is careful network planning. This involves the strategic placement of network elements like routers, base stations, and access points to provide optimal coverage and capacity. It also considers future scalability and potential interference scenarios. Machine learning algorithms can automate complex and labor-intensive tasks like network planning, tuning, and optimization. They can help in determining optimal placement of network elements, adjusting parameters to improve performance, and dynamic balancing network loads. An important aspect in this planning is also the geography, in the case of cellular networks, or in local networks, the layout of the building. Thick walls will decrease the signal strength, while other electronic devices may cause signal interference. This should be taken into account. Careful network planning also involves identification and elimination of potential dead zones, which are areas with weak or no signal coverage. The next important topic is related to traffic. When in the old times, a simple phone line was sufficient to meet the needs of the users, namely making phone calls, the rise of connected devices, high-definition content, online gaming, cloud services, and Internet of Things, so many of those, have led to significant increase in data traffic. Managing this growing demand while maintaining a high quality of service is a significant challenge. The technical term here is load balancing. In times of high network demand, leading to network congestion, optimization ensures the load is balanced across all available network resources to prevent overloading and ensure smooth service. AI can analyze large amounts of network data to predict future network conditions, such as demand surges or potential failures. Thus, predictive analytics allows network operators to proactively adjust network configuration and resource allocation to prevent problems before they occur. To illustrate this, imagine a situation when tens of thousands of people visit a sport event at a stadium, and everybody wants to have a good connection to stream videos. Alternatively, seaside resorts see population jump in summer several times the number of people that live there in winter. This also means increased network traffic. These are events that can be easily predicted. Well, we know when there is a sport event or when the summer season starts. But for finer fluctuations, AI models are much more efficient since they can respond faster. In the long term, predictive modeling can assist network scaling by predicting growth in demand in future and help network operators to plan where to install additional infrastructure. As commonly encountered in AI applications, these models require representative datasets for training. Somehow related, AI can optimize the allocation of network resources based on real-time demand, which is called dynamic resource allocation. For example, it can dynamically allocate bandwidth to different applications based on their current requirements, ensuring that all applications get the resources they need when they need them. Modern networks incorporate a diverse range of technologies, from older 3G and 4G networks to the new 5G networks, Wi-Fi and IoT technologies. AI can facilitate the seamless integration of various network technologies by dynamically managing resources and coordinating operations across these networks. There are several other aspects where AI can be used in wireless network optimization. Energy efficiency by adjusting the power consumption of devices according to their use. Automated troubleshooting by readjustment of the network if some of the nodes fall. Anomaly detection and security. In addition to network failure, this also includes detecting possible cyber threats such as DDoS attacks and implementing countermeasures in real time. The trend in the field of networks is development of self-organizing networks that can optimize, configure, plan, and heal themselves. Wireless networks are important components of our everyday lives. For the users to have quality service depending on their needs, and these needs can change in time, networks should be carefully set and maintained. We looked at some aspects where AI can assist, but there is more to explore. At the end of the unit, you'll find several questions to test your knowledge. Here is one of the questions. What is the primary goal of wireless network optimization? To improve network performance and user experience? To increase the number of connected devices? To eliminate the need for network administrators? Or to eliminate the use of wired networks? Which one is it?